Broadly, chemical reactions are grouped into four types: combination, decomposition, displacement, and double displacement. And based on energy, we also identify reactions as exothermic or endothermic. As you see on the flowchart on screen, this is the foundation of understanding chemical behavior, and it's essential for both lab work and industrial chemistry. Let's begin with one of the simplest types, the combination reaction. As the name suggests, two or more substances come together to form a single new product. Here's the general pattern: a plus B gives AB. Take this example: calcium oxide, also called quicklime, reacts with water to form calcium hydroxide or slaked lime. You'll notice heat is released during this reaction, making it exothermic. In fact, this very reaction is used in whitewashing. The slaked lime reacts with carbon dioxide in the air to form a hard, white coating on walls. Neat, right? So combination reactions are not just theoretical, they're right there in your home. Now let's flip the script. What happens when a substance breaks down into simpler substances? That's a decomposition reaction. The general form is A breaks into a plus B. For instance, when we heat ferrous sulfate crystals, they decompose into ferric oxide, sulfur dioxide, and sulfur trioxide. Written as 2FeSO4 solid on heating gives Fe2O3 solid plus SO2 gas plus SO3 gas. Depending on what drives the breakdown, decomposition reactions can be thermal, by heat, photolytic, by light, electrolytic, by electricity. These reactions are often used in chemical industries to extract metals or purify compounds. Watch the test tube on your screen, the green crystals turning brown and releasing gas. That's chemistry revealing its secrets. Next, let's talk about displacement reactions, where one element pushes another out of a compound. Think of it as a game of reactivity. The more reactive element takes the place of a less reactive one. General pattern: A plus BC gives AC plus B. Here's an example: when zinc metal is added to copper sulfate solution, the blue solution fades and copper settles down. Spoken as Z in solid plus CuSO4 aqueous gives Z in SO4 aqueous plus Cu solid. This reaction is governed by the reactivity series, a list ranking metals by their ability to displace others. In labs, we often dip iron nails into copper sulfate and watch the magic unfold as the nail turns reddish brown with deposited copper. You're literally watching one metal oust another. Now let's look at double displacement reactions, where two compounds exchange ions to form two new compounds. It's like chemical swapping. The general reaction looks like this: a plus CD gives AD plus CB. Let's take sodium sulfate reacting with barium chloride. The result? A white precipitate of barium sulfate and sodium chloride. Written as Na2SO4 aqueous plus BaCl2 aqueous gives BaSO4 solid plus 2 NaCl aqueous. The white precipitate, that solid you see, is barium sulfate, which signals the reaction has occurred. Such reactions are commonly used in qualitative salt analysis to test for the presence of ions. Chemistry gives you instant feedback in the form of visual cues. Amazing, isn't it? Did you know that chemical reactions can either release or absorb heat? Let's explore exothermic and endothermic reactions. In an exothermic reaction, energy is released. A classic example is carbon reacting with oxygen to form carbon dioxide and heat. That's C plus O2 gives CO2 plus heat. This kind of reaction powers fireworks, combustion engines, and even your body heat during digestion. On the other hand, endothermic reactions absorb energy. For example, nitrogen and oxygen combine with the help of heat to form nitric oxide. That's N2 plus O2 plus heat gives to NO. Endothermic reactions are used in instant cold packs, those used in sports injuries. You can visualize both on screen. Exothermic reactions dip down in energy diagrams, while endothermic ones climb upwards. Let's quickly revise what we've learned about chemical changes today. We explored four key types of reactions: combination, where substances join together; decomposition, where compounds split apart; displacement, where one element replaces another; double displacement, where compounds exchange parts. We also saw how reactions can be exothermic, releasing heat, or endothermic, where heat is absorbed. These reactions are more than just equations, they help us understand how rust forms, how bleaching works, and how medicine interacts in our bodies. So, to sum up, understanding the types of chemical changes gives us the tools to decode the chemical world, whether it's in your lab, your home, or a factory floor. I hope this session helped you connect chemical reactions to real life, from whitewashing walls to how instant cold packs work. Catch you in the next class where we'll explore how to write chemical equations using symbols, valencies, and proper balancing techniques. Until then, stay curious, observe the reactions around you, and let chemistry keep surprising you.